Now I am going to explain next very important part, and it is secondary batteries or secondary cells. So you know, secondary cells or batteries are those which can be used again and again by charging. That is, they are not exhausted just by single use like primary cells. Primary cells, you know, like dry cell, button cells, they can be used only once, and if their life is over, they are exhausted. They cannot be used again and again by charging. So secondary cells are those which can be used again and again by charging, and there is the electrochemical reaction on drawing current. There is chemical change, they are exhausted, or there is some formation of compounds, and on passing current they are, you know, original chemicals are reversed. So in secondary cells there is the reversible reaction. So secondary cells we have to study. First is lead storage battery. Lead storage battery. Lead storage battery. They are also called as lead acid battery. Lead acid battery, or they are also called as acid accumulator or lead acid accumulator. Accumulator means they accumulate the current. So this is one. The second point is nickel cadmium. Nickel cadmium batteries. Nickel cadmium battery or nickel cadmium cells. You all know lead storage battery is used in inverters, in all the automobiles, two-wheelers and four-wheelers. All they have sulfuric acid as an electrolyte, and lead plates and lead dioxide plates are as, you know, electrodes. Now we'll see first about the lead storage battery. See how. Lead storage battery or acid accumulator is made up of lead plates as anode, lead plates as anode, and lead grid filled with lead dioxide, lead grid filled with lead dioxide PbO2, or a spongy lead as cathode. A spongy lead means it is something, you know, it is oxide of lead, and it is called as a spongy lead. Its nickname is a spongy lead. So, and coming to the grid. So grid means, you know, mesh. So very fine, you know, grids are there. Very fine grids are there, just like the mosquito nets which we use in the windows to save from this. So this is the grid. Very fine grids are there, and there are the, you know, very small places, very small, you know, gaps, and the spongy lead or lead dioxide is filled inside. So it is there. The lead as you know, here lead grid, it is used, lead grid. So this is the lead grid. This is lead grid. Lead grid, and then it is filled with, it is completely filled. It is completely filled with lead dioxide. So this is PbO2 layer. So PbO2, a spongy lead, is compressed. So this is the point. Now coming to real portion. So the two type of plates. One is the lead plate, and other is this lead grid filled with PbO2. This is the different type of plates are separated by hard plastic separators. So the two different plates are separated by hard plastic separators. Plastic separators, or you can say the partition, they are just like cardboard plates. And why? It is because it prevents from the short circuiting. You know, one is having the negative, other is having the positive. So this is there. So they are separated. So if there is one plate here and one plate is here, so there is the separator like this. So this is the separator, and suppose this is positive and this is negative like this. Now see how. Now we have the point that lead plates as anode. Lead plates as anode. So at anode, it is negative, there is the oxidation. So lead Pb solid, it undergoes oxidation and there is formation of lead ions. Then a spongy lead as cathode or plus. So here there is the oxidation and here there is the reduction. Oxidation and reduction takes place. So now we'll see how it works, or the working of an acid accumulator. So as you know, at anode is negative, there is the lead plate. So lead plate, lead solid, it undergoes oxidation. So there is the oxidation. Electrons are produced and lead ions are produced. Now at cathode, it is plus. So if oxidation is going on, so here there must be reduction. And there is a spongy lead. Actually lead grid is very small amount. Lead grid only supports, or it is there to hold together the lead dioxide or a spongy lead. So real reaction takes place of the spongy lead. So PbO2 solid plus sulfuric acid aqueous, sulfate ions aqueous, or you may write down here sulfuric acid, and the electrons, they are taken up, and as a result there is formation of lead sulfate solid and there is formation of S2. So, or you may write down here 2S2. So, what is very important? That when we draw current from lead accumulator or lead acid battery, what happens? There is the formation of water. So, what happens? The strength of the electrolyte is decreased. So, in this, the approximately 38% sulfuric acid, 38% sulfuric acid is used as an electrolyte. This is very important point. 38% sulfuric acid is used. 38% sulfuric acid means 38%, 38 gram per 100 ml of is used as an electrolyte. Now coming to the net reaction. What happens to the net reaction? So we'll see the net reaction. So, in net reaction, there will be the reaction, there will be the combination of the two. So, Pb, solid from the anode, then there will be PbO2, solid, this is from the anode, this is from the cathode, plus there will be sulfuric acid, because sulfuric acid, 38% it is used as an electrolyte, so there will be sulfuric acid, aqueous, and as a result of this, we have to write down this. So there will be PbSO4 plus 2s2. So there is the, of course we write here 2 to balance. Now you have to see that this is the net reaction, this is the anode, this is the cathode. So this lead sulfate is formed, lead sulfate is produced in the reaction, and when we draw current or when we are taking the current from the battery becomes weaker because of the formation of water. The electrolyte becomes dilute, and so the capacity of the battery becomes weak. So we have to charge the battery. Now see next. Now this is the reversible reaction. So this sign of arrow, this arrow sign, arrow mark indicates that the reversible reaction takes place inside the secondary batteries, all the secondary batteries, and this is example of acid accumulator. So on taking current, or we can say on discharge, both are having the same meaning. When we are taking current, when we are drawing current from the battery is going to be discharged. So on discharging, there is the formation of water and this lead sulfate. And so as the strength of electrolyte, because electrolyte is 38%, naturally when the water is more, the concentration of water increases. So electrolyte becomes weaker, and so amount of water increases. Now then opposite questions. On charging, what happens when we charge the battery? All the electronic equipments like inverter, two-wheeler, four-wheeler, all have acid accumulator. You all know this. And so there is the automatic system. In inverter, what happens? When the mains goes off, what happens? Our supply in the homes is maintained on the inverter. And as soon as there is, mains supply is on, inverter starts, charging of the battery. Or the current supply to the house is blocked and the mains is on. Then what happens? Inverter starts charging the battery itself. Same case takes with the, all the two-wheelers and four-wheelers. There is the automatic system. There is the cutoff system. So this is there. Now coming to actual representation of the diagram. So it is basically the hard plastic body and the lead plates. This is lead plate, this is a spongy lead plate, and the two plates are separated by hard plastic separators, and there are different cells. See very carefully. This is one compartment. All the batteries, they are made up of different compartments. So this is one compartment. Now this is going to be the second compartment. So this is separator, Separator, simple, it is just like plastic sheet. Let this be the, minus, this be the plus minus. Again here we have the 1, let this be the plus, this be the minus. Again there is the plastic separator. Then in the third cell, again the same condition, and here there is the third one. Now coming to this plus and this minus. Now this is filled with approximately 38% sulfuric acid solution. Now next what? The different plates of same type, they are connected in parallel. So this plus will be connected to plus, and like this. This minus will be connected to minus, and this. So ultimately here there will be the minus terminal, and here there will be the plus terminal. And now this is it is enclosed by separator. So this is the function you all have seen. You have the inverter at our homes, you might have seen in bikes or two-wheelers also. This is the basic construction. So the number of cells, so these are the cells, 3 cells. So it depends on the number of cells, depends on the type of the battery, depend on the type of battery and the current capacity. What is the current capacity of the battery? So this is all about the construction and working of the lead storage battery. But now this, it has limitation. One limitation, that it is very heavy. You all know, inverter battery is very heavy. Second point is that it requires frequent maintenance. So two are main important drawbacks. It is heavy and requires frequent maintenance. Other point is that it has less lifetime, and the merit is one. It is cheaper. So this is all about the lead acid accumulator. Now coming to next important class of secondary cells, and it is nothing but it is a nickel cadmium cell. You all know nickel cadmium cell or batteries, they are available in the market as rechargeable cell. You all know they are used in toys, they are used in photo cameras, etc. So variety of uses, and so except they are rechargeable, and they are made up of cadmium plates as anode, and nickel hydroxide, nickel N3 gel as cathode, and potassium hydroxide or sodium hydroxide in gel form as an electrolyte. So this is cadmium plate, nickel hydroxide. So nickel hydroxide is absorbed in a special type of paper. And so we have the nickel plates, very fine nickel plates, and so the two plates are separated by plastic separators, and they are wrapped around each other. So first layer, so this is the first layer of cadmium plate, then there is the plastic separator or insulator, and there is the third plate of this, and so they are wrapped around each other. So this acts as minus, this acts as place. So they are just wrapped like this. If you see like this, so they are very compact from the top. It is there, and it is double layer. So if we draw, so one portion, it is very compact, and you see from the top it is like this. It is simple, like except nickel cadmium is written, and here there is the terminal, so it is plus, here it is minus, and they are rechargeable. So we'll see the net reaction. Now coming to the working of this, so there is the cadmium solid, and of course we have the nickel in the 3 oxidation state. It is also basically solid. You can say that in the form of gel, and there is the chemical change, and on chemical change the cadmium is converted to cadmium oxide solid, and nickel here is in the state of +3. So nickel will be converted to +2, and in this, there is formation of one water molecule. So as this reaction is reversible, so this is on drawing current, or where we are taking current. So it is very similar to the acid accumulator. Water is being produced, and here this is on charging. This is on charging. What happens? The reversible reaction takes place, and this nickel in +2, it is converted to nickel to +3, and so the cell works, and it can be used again and again by charging. Now coming to the last part of this, what are the merits and what are the demerits? First we'll say about the merits. So merits are limited. That first is they have much larger life than acid accumulator. Acid accumulators have limited life. They are very, having very large lifetime. And second is that they are lighter. They are lighter. They are much lighter than that of the acid accumulators. Now coming to demerits. And so demerit, it is very limited. It is very much expensive. It is very much expensive. It is much expensive. It is much expensive. And because it uses cadmium, it uses nickel. So this is all about the nickel cadmium battery.